Good afternoon. I'm Don Bailey. I'm a principal security geek on the AWS security team, and my day job is protecting AWS customers and AWS itself.
And I'm Josh Jelek, security geek and road warrior with AWS Professional Services, helping customers achieve their own security objectives on AWS.
This is Sec 308. We are wrangling security events in the cloud. So what to expect from this session? We'll be giving a tactical follow-on to our previous year's talks on intrusion detection and incident response for AWS customers. We'll be discussing example security events to monitor for and also how to handle those within your AWS environment. These examples are meant to spark ideas for increasing your own security agility within AWS. So we're going to point out a few AWS mechanisms and resources for you to leverage, but you have to keep in mind that there may be more than one way to catch a cat burglar, so reinvent as necessary. Now, as mentioned, this talk is going to build upon a couple previous talks, and I'm going to summarize those quickly. In last year's intrusion detection in the cloud, we introduced the concept of AWS-specific traditional intrusion detection, but not so traditional because it's applied to AWS environments. And we suggested prerequisite AWS knowledge and configuration for an AWS-specific intrusion detection system and introduced key concepts like security roles, as well as write-once storage for immutable logs. We also talked about key services to leverage for building your own AWS-specific intrusion detection system, pointing out that there were AWS-specific events that you should monitor for and non-obvious behaviors that you should monitor for as well. Now, in last year's incident response in the cloud, we encourage you to make sure that your existing IR process takes into account your AWS environment. We suggested more prerequisite knowledge, and we discussed mechanisms and tactics for mitigating and investigating AWS-specific security-related events. Now, for example, we talked about interns leaking your AWS credits to or credentials to the internet, and how to resource people around you to adjust your IAM policies to constrain certain things after the fact and exposure. We also provided step-by-step instructions for performing traditional incident response, but within the AWS environment, like live memory capture from an EC2 instance and analyzing that for particular activities. Now, if you missed either intrusion detection in the cloud or incident response in the cloud, then all you need to do is go to YouTube and search for intrusion detection in the cloud or incident response in the cloud. So what are we talking about with wrangling security events in the cloud?
Sure. Today's talk is an in-depth discussion and demonstration about security event response. We're going to be talking about the types of security events to prepare for, how to go from detection to recovery of an event, how to investigate an event and use that information to help protect from the same event recurring. We're going to reinforce this with some demonstrations using the AWS Management Console, the CLI, and SDKs, and highlight particularly helpful and powerful services and features of AWS.
Now, when we're talking about events within a AWS environment and security-related events that we would like to pay attention to, those might be configuration changes that could impair us from detecting or understanding events in the first place, naturally. Those could also be activities that are inconsistent with our expectations or that violate explicitly policy that we might have. Resources that are unexpectedly no longer available, or maybe some resources that have suddenly become more available than we wanted in the first place. It's important to point out that there may not be a commercial product that you can actually plug in, simply turn on, and that will detect all the events of concern for you and your AWS environment. So you should take a careful look at your AWS environment, look at your operations within AWS, and develop custom event detection signatures to maintain awareness and trigger the actual appropriate response. Now, if you've been a security geek for less than a week, there's a good chance that you have seen something that looks like this. It's a security event process workflow circle of life Simba. Usually in textbooks, the protect part comes first in the security goodness flowchart mantra thingy, which is completely disconnected from the real world. If this is your second week on the job as a security geek, then there's a good chance you are facing something that looks more like this. When there's a breakdown as far as protect is concerned, we wind up wrangling a security event. And so we're essentially left with having to detect what happened, then recover from that particular event. Let's see if we can go back to the previous slide. There we go. Detect what happened, recover from that particular event, investigate what the root cause was, and then once we've actually investigated that, then we'll know what we need to do to protect from it in the future. So Josh, when we're talking to security geeks, what gets them excited about using AWS to deal with the flowchart that we just talked about?
Sure. Well, the ability to use the CLI or SDK within AWS to programmatically interact with our APIs is very empowering for security professionals. With simple API calls, we can get an inventory within AWS and what's happening to it and how it is changing within our accounts. And leveraging these services, you can start to build your own detection and alerting mechanisms and even begin to automatically respond to events. So building automatic response lets you sleep peacefully when something goes bump in the night. So in order to proceed through this talk, we're going to be focusing on CloudTrail. And if you're not familiar with CloudTrail, it's a service that records AWS API calls for your account and delivers log files to you. So if you take one thing away from this talk, make sure that you turn CloudTrail on in all of your regions. So real quick, let's take a look in the AWS console and determine where to turn CloudTrail on. So when you log in the console, you're presented with a variety of services, but under management tools, you're going to find CloudTrail. So let's go ahead and click on that. If this is the first time you're looking at it, you're going to be presented with this page. Go ahead and click on Get Started Now. You're going to need to choose a name for the trail as well as the Amazon S3 bucket in which you want the service to store the logs. Once we do that, additionally, we can click on the Advanced button there. Here on the Advanced pane, it lets us configure an Amazon SNS notification when files are delivered. This is particularly useful if you want something to be triggered whenever a new log file is ready, rather than having to continuously pull for new log files. So let's dive a little bit further into CloudTrail, CloudTrail events specifically. CloudTrail event is a record in JSON format that contains information about requests for resources in your account. And so this provides or describes what service was accessed, what action was performed, and any parameters for that action as well. So let's take a look at a quick example of a CloudTrail event record. If we scan over the areas that I've highlighted in white here, you'll notice that the IAM user named Alice made this request. And specifically, back in March 2015, she made the create user API call to the IAM service from the IP address that we're going to be referring to throughout this talk is 55.55.55.55. Additionally, we noticed that she created the user Bob.
Now, once you've actually turned CloudTrail on, then you're going to notice when you're looking at your CloudTrail configuration page that CloudTrail is on. If you turn CloudTrail off, you are going to be presented with a pop-up dialog asking, are you sure you want to stop logging? Assuming you click continue, you're going to notice that CloudTrail is off. Speaking from the perspective of a security geek, it's probably a good idea to know if and when CloudTrail is actually turned off. But I'd like to not have to visit every CloudTrail configuration page to figure that out. So Josh, is there a way that we can do this programmatically?
Sure. There is. With CloudTrail turned on, you actually get a record of the API requests that turn CloudTrail off. And so here's what that API request would look like. You'll notice highlighted in white, the stop logging API request was made to the CloudTrail service, specifically in the US West 2 region. So I would prefer, as mentioned, to be alerted to this change without having to check CloudTrail continuously every 5 minutes of my life. We can do that by using CloudWatch Logs. So CloudWatch Logs is a service that lets us monitor and alarm for specific phrases, values, or patterns. So if we go back to our previous example, in CloudTrail in the management console, we can go ahead and click on Configure under CloudWatch Logs. And then after choosing a new or existing CloudWatch Logs log group, we can go ahead and click Configure. And then on this page, we're just going to be accepting the necessary roles and permissions so CloudTrail can actually deliver the events to CloudWatch Logs. So if you click on this blue link here, this will actually take you into CloudFormation and set up a number of metric filters and alarms within CloudWatch for some basic security and network-related API calls. So if you're a go-getter, though, and you want to manipulate this and add some additional API calls for services that might not be already included in it, you can certainly do that. If you click the URL down here at the bottom, it'll take you to a documentation page that explains the CloudFormation template. And so you can then download it, edit it, and add additional API calls for investigation. So if we look at this event that we're talking about, where someone would turn CloudTrail off, we can go ahead and open up that CloudFormation template, and you'll be presented with something like this. This is a AWS CloudWatch metric filter that's defined within a CloudFormation template in JSON format. The important thing to notice is what I've highlighted in white here. I'm specifically filtering CloudTrail event records for the event name of stop logging. I can then use this metric in combination with an alarm to send me a notification whenever it's detected. And so here's what that alarm would look like. I'm specifically requesting for the metric name of CloudTrail event count in the previous slide. And you'll notice at the bottom, I'm saying if the threshold is 1 within a 300-second period, then I want to be notified. But let's assume it did happen and you detected it and somebody turned CloudTrail off. What would you do now? Well, you're going to turn it back on. And it's pretty simple to do this. There's a little switch at the top right. You click it, it's back on. But let's investigate. As CloudTrail will log the event stop logging, we can see who made the request to do this. So if we pull up the CloudTrail event, we can see the IAM user named reinvent SEC 308 was the individual who made this request, and that the request originated from our known IP address. So now that we know what happened and that it was performed for a demo, how could we protect this from happening in the future? Well, we could simply add an IAM policy to our IAM groups or roles in order to deny permissions we don't want our users to have. So in this case, I want to block myself from turning CloudTrail off or actually being able to delete the trails to begin with.
And yes, we can actually use the CloudTrail API to turn CloudTrail back on. We don't actually have to go in and click buttons to do it. Sure. So that's a great example of a feature within an AWS environment that we would like to stay aware of and make sure that it stays on. We'd like to know when it's off, and we also need to know how to go back and remediate that. Another AWS security-related feature that we'd like to pay attention to and make sure that it's staying on would be multi-factor authentication, or what we like to call MFA. So multi-factor authentication, if you're not familiar with it, requires unique authentication codes for access to AWS websites or services. You can either have a nice little hardware token or a virtual MFA device. You enter these codes manually when you're logging into the AWS Management Console. They accompany your login, or you can have those codes accompany an API request in a programmatic fashion. And if you have to configure that, you do it through the Identity Access Management portion of AWS. If you go into the Management Console and you look under Security and Identity, you'll find Identity Access Management. If you look at the actual users within there, you'll find, in this case, a test user. And if you want to find where to configure MFA, you'll have to scroll down a little bit. You'll get to Manage MFA Devices. At Manage MFA Devices, if you click on that, you will be presented with either choosing a virtual MFA device or a hardware MFA device. So if you're familiar with virtual MFA devices, such as the AWS Multi-Factor Authentication app or Google Authenticator or Authy, then you can use one of those as your virtual MFA device. And choosing that, you'll have to make sure that you have that software pre-installed. You can then scan a QR code that will bootstrap that actual authentication, and then entering in 2 sequential codes will actually get that MFA activated. And you'll get presented with a nice little screen that says it's activated. And now when we go back and look at that actual user, we'll see that multi-factor authentication is enabled for that particular user. But you can click on Manage MFA Device again, and you'll be presented with some options here, which include deactivating MFA. And if you decide that you're going to deactivate MFA, then it's going to deactivate MFA. It would be nice if we could look for events that would indicate that somebody has deactivated MFA. And we can do that through CloudTrail. So if we go through CloudTrail and look at the actual API call associated with that, we're looking for deactivate MFA device as the actual event that has occurred. And we can find that in an actual CloudTrail record, deactivate MFA device. This is what it would look like. Notice the event, deactivate MFA device.
So the question would be, how do we automatically detect that event? Well, if we circle back to our previous example using CloudFormation, we can set up a metric filter to detect the deactivate MFA device API call. And then combining this with the CloudWatch alarm, we would be notified of the event through email or text or something. So let's assume it does happen. What is our course of action to recover from the event? Well, we could simply force the user to reconfigure their MFA device, but we'll need to investigate to find out who to contact. So if we go back to our previous example with the CloudTrail record, it tells us when the event happened, and the source IP address is our known IP address, which is good. And then we notice that the user Bob was the one who deactivated his account, so we'll need to go talk to Bob. But how can we force individuals to use their MFA devices, or how can we protect this from happening in the future? We actually have a blog article specifically talking about that subject. So check it out, determine if it's appropriate for your environment. It'll also show you how to set up policies to make sure users can reactivate their MFA device.
So that's two examples of looking at our AWS environment, specifically security-related features, making sure that they stay on, making sure that if they are turned off, we're aware of it, and we can go back and actually remediate that. But when we're looking at an AWS environment, we're not just concerned about the configuration, and certainly not just of the security features. We're also concerned about data that's within the account. One of the places that we like to store data, S3. So if we look at an S3 configuration for an account, and we look in there and say like a particular bucket, in this case, we're looking at the reInvent 2015 Sec 308 bucket. We'll have, in this case, a few folders. One of them happens to be prod, which might stand for, I don't know, production. And then, of course, if we look in the production folder, there happens to be an important file. It's important because it says important.txt. If we look at the properties of that bucket, we want to make sure that there are certain security best practices configured, right? Such as logging. We want to have S3 bucket logging turned on. That's pretty simple to do. We specify where we would like to actually store logs associated with our S3 bucket. We also want to turn on object versioning. If you're not familiar with S3 object versioning, we talked about this last year. It's the ability to actually have versions of files kept such that if somebody accidentally deletes or overwrites a file, you have a version of that file to restore from. And we'll keep those back any number of different versions as you continue to overwrite. And certainly if you accidentally delete, it's nice to have that version available. Turning that on is fairly simple. You go into the bucket configuration or bucket properties and enable versioning. We're going to let you know that we're storing extra versions, which is extra bits, which will incur additional costs, such as those bits do. And once you've enabled versioning, you're going to see that this bucket has versioning turned on. Now we've turned on bucket logging and we've turned on bucket versioning, and that's good. I would like to know when that important.txt file goes away. And do I have to continuously review my logs in order to determine that important.txt is no longer there and I need to actually restore from a version? No. We can actually enable notifications for S3 events that might concern us. So Amazon S3 notification feature enables you to receive notifications when certain events happen within that bucket. To enable those, you're first going to have to add a notification configuration identifying the events that you are actually concerned about. That might be removing an object. We can do that by going into the bucket configuration, or the bucket properties, excuse me, and selecting events. And we can configure the type of event that we would like to look for. In this case, we are looking for object removed. We can also specify a prefix. So in this case, we're looking for anything that's going to be removed from the prod folder. And then we're going to configure an SNS topic that we would like the events to actually go to. So anytime an object is removed from the prod folder, please send a notification to, in this case, the S3 delete events SNS topic. And we can name that event, in this case, prod object deletion. If we go into the actual SNS topic, we can configure that topic to have subscriptions to it, right? And maybe a subscription to that could be, I don't know, an email address that is security_team@yourcompany.com. Such that if somebody actually goes into that bucket, right-clicks on the object, deletes the object, it's not going to exist in the bucket anymore, right? However, the security team is going to be aware of it because they've actually received a notification via email telling them that, hey, important.txt no longer exists within the bucket. Now, recovering from that, an object deletion, you just restore from the deleted file from a previous version, right? We turned on bucket logging, right? So we know that something's actually occurred within the bucket. We've got versioning turned on, so now we can actually restore from a previous version. You can do that through the management console. It's just a couple clicks away. You can also do that through the command line interface or an API using the copy object request. Now, if you've enabled versioning after you've actually put objects within a bucket, the version ID is going to be listed as null. That's okay. You can still specify null as an actual version to restore from. Now, where do we actually find the versions so that we can restore from them? If you go back into the bucket, you'll see that there's a button up there that says versions, hide, or show. Let's click show. And sure enough, our deleted versions are still there, and we can restore from those. We restore through the management console. We can download a deleted version, and we can upload it back into the bucket. and now our important.txt file is still there. We can do that programmatically if we list object versions so that we can actually see the versions of previous files. Then we can use the copy object. We can use the copy object of S3 API to actually specify the restoral of that particular version. Notice here it's specifying the copy source as a URL with the version ID, and in this case, specified as null. Now, if we don't have versioning turned on within the prod bucket or prod folder of a particular bucket, but we may have backup copies of files within another bucket, then we can still restore from backup files, certainly. And of course, within that backup folder, we would also have logging and versioning turned on, and it's just another copy source command, or copy object command, excuse me. Now, investigating the actual deletion event, right? Within the actual event notification that we received is the source IP of where it came from, as well as the principal associated with that particular request. And so then we can use that to actually go and investigate, potentially talk to the intern that decided he was going to delete important.txt. Now, if we want to protect from this action occurring in the future, other than deleting the intern, then we're going to use bucket versioning, right? Just turning on bucket versioning, that's a great feature that will protect from inadvertent deletes or overwrites of objects and interns. If you want to consider additional protective measures, look at the actual policies associated with credentials that have the ability to access S3 buckets, right? You can specifically disallow the S3 object removal capability. And then if you want even better protection for those objects that you're truly concerned about and that should never be deleted, you can use an additional layer of protection using MFA delete, which means you're going to have to generate a code and accompany it with an API request to delete an object. There will be no inadvertent deletion at that point.
Great. So let's look at another example of a security event that some customers are concerned about. They would prefer to know if someone is logging into their AWS account from an unknown IP address. So you'll notice here I'm going back again to the CloudFormation template just as before, and we can configure a new filter pattern. So in this scenario, I'm making a filter pattern for the console login event, and specifically I'm also looking for the known IP address for our office within a subnet. So if we do get an alert and we detect the login anomaly, we'll want to recover as quick as possible. One option we have is to configure a null IAM policy to deny all permissions to the user. And the policy would look something like this. But we'll want to investigate a little bit further. The console login record will tell us the source IP and the user, but we'll want to determine if that user made any changes after they logged in. So we'll need to go through CloudTrail looking for that principal or user and see if anything else happened after the original console login. But going forward, you can certainly protect yourself in the future using IAM conditional statements. So applying a condition statement for the source IP address, you can configure that for groups or roles as necessary in order to restrict access.
Great. So an additional area of concern for customers within an AWS account is the launch of instances within security groups that are completely open to the internet. And what is an open security group? Again, if we're allowing the entire internet to access all ports and protocols on an EC2 instance, that's probably not a good idea. In the case of a web server, it's likely okay that we allow the entire internet to access port 80, port 443, but not all of the other ports on that web server. Now, your policy might vary. So in the case of administrative access, remote administrative access to EC2 instances, you might say that it's okay for anybody on the planet to be able to SSH to your EC2 instance. You may also say, and I would recommend, that only people that are coming from IP address ranges associated with your organization should be able to access remotely and administer your EC2 instances. The point here is that creation and change within security groups should be low in velocity. This should not be something that's changing very quickly within your environment, specifically with resources that you are very concerned about and will remain static for some time. So you should be able to monitor these types of changes, and we have an actual service that allows you to do that. AWS Config will perform resource inventory. It will also give you configuration history, and it will notify you on configuration changes for the things that you're concerned about. So it discovers your existing AWS resources. You can export the inventory of those AWS resources all the configuration details associated with that. It's great to present to auditors. Security geeks should absolutely love AWS config, and I do. If we want to find AWS config, it's within management tools. Clicking on there, you'll be presented with this if you haven't started now. Start now, and you can start to select the types of resources that you would like to record configuration changes for. In this case, we can select security group. And now AWS config is going to monitor our security groups for any changes. We can have logs delivered to an S3 bucket of our choosing, and we can also have notification of configuration changes sent to an SNS topic. Now, AWS config is going to need permissions in order to read the environment, understand the resources that are there, and actually deposit logs and send notifications, so you're going to have to allow that. And once you've done all of that configuration, you will find out that recording is on. Now, how do we actually detect an open security group event within our AWS environment? Well, we subscribe AWS config to the notification topic, and we filter notifications for creation of any security groups that would be concerning to us. So you could use your email application to create filters or alerts for things such as security group and create. You could go a little bit deeper and look for things that are associated just with the security group, and more importantly, port ranges or IP ranges that are concerning to you. And anytime that there are changes within your AWS environment specific to security groups, you'll get a notification. And detecting, in this case, an open security group event is as simple as looking for the IP protocol as -1, which translates to any, and looking for the IP range as 0, all, translating to internet. Now, how do we recover from an open security group event? Well, if you're responding soon enough to an open security group event, and the actual creation of that security group, if there are no instances that are launched already within that security group, then you can just simply delete the actual security group. Otherwise, if there are running instances already associated with that security group, you will have to move or assign those running instances to another security group. Then you can delete the offending security group. Now, that new security group might be a security group that has no ingress or egress associated with it. Now, if the change event that occurred that allows internet access to all of the EC2 instances within that security group happens to be associated with the default security group, you cannot delete the default security group. However, you can change the rules associated with the default security group, and that might be adding no rules. So we can do this through EC2, Management Console, click on Security Groups, look at the offending security group, right-click, delete security group. Pretty easy. We can also do this through the command line interface, EC2 delete security group. Make sure that you specify no dry run. That means it's actually going to occur. Now, if we're investigating this, we'll look at the actual AWS config change notification. We're going to note the time, the action, the security group ID, and then we need to correlate that principal and source IP associated with the API call that will be in AWS CloudTrail. And if possible, you want to actually talk to the person who performed that actual event and understand their intent. Did they actually mean to open up a security group to the entire world for that particular EC2 instance? Maybe it's an unexplained event and it's an external act or it's potentially malicious. In any case, the way that we're going to protect from this is to appropriately constrain or deactivate the associated credentials if we need to. Security group changes, and particularly those that are within production, they're not going to be very frequent. And so you should maintain a high level of vigilance here.
Great. So we've looked at several security events so far. We have one last one. Unapproved AMIs. And so this is a concern for a number of customers. But just real quick to recap, AMI is an Amazon machine image. And there's a number of places that you can use them or get them from. So a public AMI or from the marketplace, or you can have your own private AMI. But these are used to launch EC2 instances. And so some customers will choose to have an approved AMI, and then they harden them. Sometimes it's referred to as a gold AMI, but these are used to launch approved EC2 instances within their account. So we would like to be able to detect if an EC2 instance is launched using an AMI that has not been hardened and approved within the account. And so the question is how you compare launch EC2 instances against a whitelist, as the whitelist could be rather long, so it might not be useful to use CloudWatch as in the example we were doing previously. So what is the best method to do this? And this is where Lambda comes in. So AWS Lambda is a service that runs your code in response to events. It'll automatically manage compute resources on your behalf, and you can create new and interesting backend services that are automatically triggered based on customer requests. So in this case, for this example, we're going to be using Lambda, and we're going to read CloudTrail events within Lambda and be able to trigger responses based on that. So this is some Node.js code. Above this, I would be detecting and comparing against a whitelist. But in this case, I want to recover. So once I've detected EC2 instances that are launched from unapproved AMIs, I would gather those up, put them in an array, and pass that array there to the bottom to the ec2.terminateInstances function within the Node.js SDK. And then I'm able to terminate the instances that are not approved or were launched from unapproved AMIs. So we can investigate a little bit further. If we look through the CloudTrail logs, we can determine who launched the instance and where the request came from, what subnet was it being launched into. You could have Lambda send you the notification, so you have all these details. It could say, hey, I terminated this instance, but here's the details if you want to investigate a little bit further. But if you want to protect yourself from this event happening going forward in the future, you could certainly do so. You would just need to add a conditional statement in your IAM policies that explicitly define which AMIs the user is allowed to launch from. And this is the run instances API call within the EC2 service.
So what Josh just introduced is the idea of automating incident response. We're actually using one of our services, in this case Lambda, to evaluate an event and then trigger a response based on that. And most, if not all, of the pieces that you need in order to automate incident response exist in Amazon Web Services. So automated incident response is going to give your security team greater agility with dealing with these types of events. And that means you're going to go from detecting an event to actually protecting from that programmatically within your AWS environment. We're talking about lambdifying your incident response.
Absolutely. So we can use Lambda to automate the incident response that we've been talking about previously. So if we circle back to the first example of a security event that we were talking about, for someone stopping the CloudTrail logs, in this case we're using Node.js, the SDK, to detect the stop logging event to the CloudTrail service. And in this case, after we make that detection, if my matching record's length was greater than or equal to 1, I can call the CloudTrail service to initiate the start logging API event. Basically, I can turn CloudTrail back on. Let's see here. So I'll show you what this looks like. This entire talk, I've had a short demo script running in my account, doing some bad things, basically turning off CloudTrail and launching unapproved instances. So if I flip over here and refresh, you can see that the demo user is consistently making API calls to run instances with unapproved AMIs, and it's also trying to turn off my CloudTrail. But shortly thereafter, AWS Lambda service will terminate the instance as well as turn CloudTrail back on. And this has been reoccurring repeatedly throughout my account this entire talk. So let's take a look at a flow diagram of how this works. We're going to configure AWS CloudTrail to send the logs to Amazon S3 bucket. And then we want Amazon S3 to send event notifications to the Amazon SNS service whenever a new log is deposited in the bucket. So that SNS topic can have multiple Lambda subscribers. And then we can, or each of those subscribers are individual Lambda functions. And then they can check and react to different things. And this allows us to build new automatic response functions within Lambda separately and be able to troubleshoot and make sure we get it working. So to be able to create that fan out of multiple Lambda subscribers, there's actually a blog article on our website. You can check it out. It's by John Stamper, Solution Architects with AWS. But basically, just to quickly run through the steps that are heavily detailed out in that blog article. First step is we're going to turn CloudTrail on, obviously. And then we're going to create an SNS topic. We're going to update that topic policy to allow the event notifications from your S3 bucket. And then we're going to configure the S3 bucket to actually send those event notifications to the topic. After we do that, we can create an IAM role for the Lambda function. It will need permissions to be able to turn CloudTrail on or terminate the instances that are unapproved. And then we can actually start writing the Lambda functions and process the SNS messages and process the CloudTrail logs that we're passing to it. So the question would be, what can you automatically respond to? Actually, all the previous examples we talked about with the very manual process of responding to the events and recovering, we can actually automate all of those. So here's just a screenshot of multiple Lambda functions that are defined, and they're each processing CloudTrail logs looking for security anomalies or events.
So here's an example of a script that we have in Lambda that's actually looking for particular events associated with S3 object removals, making sure that we ingest the bucket name, the actual key ID, and then using that as a mechanism to perform the copy object request on our behalf. Literally, this moves so fast that as you delete the file, Lambda puts the file back in the bucket. You cannot do an LS faster than Lambda actually puts the object back in the bucket for you. It makes it difficult to delete files. We're also doing automation incident response for open security groups. In this case, we're chaining a lot of things that we're looking for in the case of create, a security group that is of IP protocol any and has a range that we're not too crazy about. And we automatically delete that security group. Makes it difficult to create open security groups. So what we're talking about is automating incident response. And we're talking about getting under the hood and looking at Lambda as a mechanism for doing that. It would be great for people that aren't necessarily interested in getting under the hood to actually have something that might do this for them and was a lot easier for them to work with. And it turns out that we've released some new features, specifically AWS config rules, that allows you to do a lot of automated incident response. So AWS config rules extends AWS config with a powerful rule system. You can use existing rules from AWS. We have a few recommendations, some ideas. We have partners that will be developing those as well. And then you can also create your own custom rules, which we've given you some examples on how to do that. If you want to find out more about AWS config rules and how to use that as an automated incident response mechanism, you should check out Sec 314, which will be tomorrow, and I believe another offering of that on Friday as well. Jeff Bars put up a blog post specifically about AWS config rules and using that for understanding and dynamically checking for any number of different compliance and security concerns within your AWS environment. Now, you might have these capabilities, and you might have these scripts, and you might even automate some of it, but it's important to understand how you're going to interact with that within your security team, and practice makes perfect when you're doing that. We recommend having incident response game days, and if you're not necessarily ready for incident response game days, then maybe tabletop exercises. And if you'd like to learn more about how to actually harden your architecture with security incident response simulations, then you should see John Miller's talk, Sec 316. In addition to that, we actually have partners, another external resource for incident response support. For example, and here to talk about directly supporting AWS customer incident response needs is Jonathan Poling from Dell SecureWorks.
All right. Can you hear me? Am I on? I'm good? All right. Thanks, Don. I appreciate it. So I'm Jonathan Poling. I'm a principal consultant with Dell SecureWorks. And so we've heard about security events and moving to the cloud and managing the cloud and operating the cloud, but what does incident response and forensics look like in the cloud? So has anyone done incident response in the cloud? No, a few people. Have you fully investigated an incident from start to finish within the cloud? Or just kind of said, I restarted it and it was done? Yeah. So can anyone say, of the few that raised their hand, that conclusively I missed nothing that was offered within AWS that could have helped assist with that incident response engagement, right? Yeah, okay, well, if yes, then maybe we can talk after for a job. So what I'm going to provide here is just kind of an IR, quick case study IR case example. What does IR look like within the cloud? What does forensic look like in the cloud? How can AWS facilitate incident response and forensics in the cloud? And also, a sort of wish list. So when we respond, things that we'd love for you to have prepared or already done by the time we respond. And then at the end, how to contact us and so forth. So we had a customer contact us that's a provider of cloud-based collaboration software. You probably know them, and if anyone in here was not using at least one of their products, I'd be surprised. So we start with the typical kind of incident response scenario, high CPU usage on some web-facing servers. They went and investigated it, found that there was a bunch of unauthorized logins from external IP addresses with supposedly compromised credentials, right? Basic incident response forensic stuff. Well, here's how it kind of changes. So the threat actors using AWS, using those compromised credentials, got into the infrastructure and were actually propagating and moving laterally and doing a bunch of things very quickly within AWS, right? So we responded to perform digital forensics on their web apps, their instances and snapshots, their CloudTrail logs, which they had enabled and collecting, and some suspected on-premise systems. So next slide. So what does the response look like? How does this differ really in the cloud? So from our perspective in our VPC and our infrastructure, we launched some EC2 instances within our own VPC, and we created an S3 data bucket for data sharing back and forth. Using IAM, we were also able to acquire snapshots of the affected customers' EC2 instances, transfer those snapshots to our S3 bucket for analysis, and receive access to their CloudTrail logs so we could start checking those out. So using some very rapidly deployed forensic tool sets, you all know how quickly you can set up infrastructure in AWS. We're able to look at the file systems, just as we would for incident response and forensics in the cloud. And we also checked out their AMIs. What were these instances built upon? Is there anything bad happening there? And also their CloudTrail logs, which provide a lot more insight than just the OS layer. It provides more insight into what was happening amongst all these resources as well. So doing this, we provided really comprehensive analysis of the incident that affected their AWS resources as a whole. So what does AWS offer us? What's really the takeaway here? So it drastically reduces the amount of time between initial identification and engagement to analysis, right? So security event data can be rapidly acquired, staged, and ready for analysis within AWS. We're not talking contact us, ship the hard drive, did FedEx, did it arrive on time, did they punt the package to your door? There's no worrying about that, right? Take a snapshot, share it with us, we have access to that data. Appropriate access can also be quickly granted to us to assist through IAM. So if you're having an issue, give us an IAM role. We can log in through the console. We can help you do whatever you need to do. And so the ability to collaborate on configuration activities directly within AWS really minimizes troubleshooting time as well. So if we say we need some logs, and it's like, well, what type of log? What does it look like? Is this the right type of log for us? Upload it to the S3 bucket. I can check it out in a few minutes. There's no uploading to an SFTP server. It's not getting caught in email. It's not wondering, how do we do this? How do we exchange this securely? It's all there, right? So it creates a very effective environment for sharing these IR resources and performing AWS within the cloud. So versus traditional IR, this really maximizes the amount you can do in a short amount of time. So we're doing a lot more in a lot less time. And when you're hiring a consulting practice like ours or anyone else, time is money, right? So less time equates to not just more effective and efficient response, but you're talking about a lot of cost savings to the company as a whole. So moving on to our wish list. So what would we want you to have prepared? What can you have prepared for us to really help us maximize our efficiency and effectiveness? So take snapshots of the affected instances, right? Super easy, click a button, one and done. Collect network and instance metadata. So what's happening in your environment? If you're using AWS config, it took a snapshot. What's changed between now and then? Create a restricted access VPC security group or separate AWS account to kind of sequester things. If you have a restricted security group, something's affected, just move it in. It's sequestered until we can get to it, right? Be ready to create temporary users and credentials via IAM. And then again, that's for temporary access for us to come in and talk with your resources to collect the data we need or just help you guys through some of the stuff. So enable and centralize CloudTrail and CloudWatch logs. You're seeing a recurring theme here, hopefully, by now with those things, very easy. And last but certainly not least, dedicated S3 bucket for sharing these artifacts. Again, that has a much greater effect on facilitating that access and making us able to respond more quickly and see that stuff in much more real time. So moving on. So here's just how to contact us. We've been at the same number and same website for a while. But by directly partnering with AWS, this has greatly facilitated our ability to perform IR and forensics, just as we've always been able to do, but now within the AWS cloud. So please come visit us at our booth, 446. We are next to Docker, so if you can just see past the critical mass of people waiting for t-shirts, we are just on the other side of that. Also, flag me down. There's much more I have to talk about, but really a short time slot here. I love to talk about it. I'm passionate about it, and so are we. And so I'm looking forward to talking with you guys about it. Appreciate it. Thank you.
Thanks, Jonathan. Now, we really appreciate AWS partners like Dell SecureWorks helping us meet our customer security objectives. It's pretty cool. I should also point out that Dell SecureWorks can also be found in the AWS Marketplace. So if you search for incident response in the AWS Marketplace, you'll be presented with their offering as well as other AWS partners that are ready to help customers with wrangling security events. We're going to go over some resources, some old, some new. Our AWS Security Best Practices white paper, available for download, as always, helps people understand what they should be doing within their AWS account. Certainly covering everything from how to configure things, but also covers things such as auditing, alerting, and incident response. New happens to be our security training. So not just actually teaching you about fundamentals in AWS security, but also SecDevOps. So actually how to have a team that is more familiar with and ready to basically perform security actions within an AWS environment. External resources include, obviously, the SANS reading room on incident response. FIRST is a good organization for incident responders, and then CERT has plenty of documentation with regards to incident response and management. Some newer external resources, incident response tools and frameworks for people that are doing it at scale. So Mozilla has released their Mozilla Investigator, which is a really good example of an incident response mechanism at scale. And then Netflix has started providing an open source mechanism to perform automated incident response at scale, fully integrated defense operations, or what's called FIDO. There are definitely some other talks that you should be checking out this week. Certainly Sec 403, which will go deeper into looking for security events using Apache Spark and Amazon EMR. Architecting for end-to-end security in the enterprise is a great talk. And if you miss any of these live, they will be available on YouTube, just like this talk. And don't forget last year's intrusion detection in the cloud and incident response in the cloud that are already on YouTube. If something goes bump in the night, you don't know who to call, and you don't have a call list already created, you can always call AWS Support. AWS Support is your one-stop shop for AWS customers, any concerns, including those that are security related. And if AWS Support cannot immediately address your concern, they will escalate internally to the appropriate technical team, and that will include AWS Security. If we're talking about AWS Security, our own resources, we have the AWS Security blog, check it out, as well as the AWS Security Center, plenty of resources there. You can always email us, aws-security@amazon.com. So in summary, you can achieve security agility on AWS, probably a little bit more than you can in some other environments. If you have certain threats that you're concerned about or certain policies that you would like to make sure are enforced, you should enumerate those and then start creating signatures as well as detection mechanisms for those. We talked about automating incident response, and you've got the tools available to you to do that on AWS, as well as new services that will give you easy ways to do it, such as AWS config rules. Remember that there's two ways that you're going to get practice in incident response. You get to choose one of those ways. We and our partners are here to help, so give us a call if you need to. Hey, remember to complete your evaluations. If you'd like to see more about incident response, and particularly training in that particular regard, where it comes to SecDevOps, give us some feedback, let us know, and we'll see what we can deliver for you. Thanks.